Hi, Brendan here from Energy Training Group with another training video. This one is specifically to help students with the system efficiency module in their grid connected with batteries course. So let's get started. First thing you need to understand when you're doing your system efficiency calcs is you've got to understand loss versus efficiency. So when we're doing our calculations, it's important you don't put in your percentages as a loss. Right, you need to input all your figures as an efficiency, not as a loss, okay, or else you get the wrong numbers. So what I mean by that is if we had 0% loss in a system, our system would be 100% efficient. 2% loss would be 98% efficient. 5% loss would be 95% efficient. 30% loss would be 70% efficient. So all you're doing is you're taking your loss figure and subtracting that from 100 to convert from a percentage loss to a percentage efficiency. You also need to make sure you can represent all your percentages as a decimal. All right, so to put your calculations into a calculator, you need to represent percentages as a decimal, not as a percentage, or else you can't punch them into your calculator. All right, so 100% as a decimal is represented as 1, 99% would be 0.99, 80% would be 0.8, 1% would be 0.01, or 0.55% would be 0.0055. Okay, so you're just moving the decimal place to get to your correct number. However, if you're struggling with moving the decimal place, you can just divide your percentage by 100 and that will convert it to a decimal. Okay, so if you did 99 divided by 100, you would get 0.99. And then you can use that number in your calculations. When you are combining efficiencies, right, you must multiply them together. Okay, you don't add efficiencies together, because if you had something that was, say, 80% efficient and then two devices that were 80 and 70% efficient, if you added them together, you would get 150% efficient, right? That's obviously the incorrect figure. So when you're combining efficiencies, you must multiply them together as a decimal. So let's say a system had a 95% efficient inverter, a 98% efficient cabling, and a 90% efficient battery. If we combine them all together, we do 0.95 times 0.98 times 0.9. We would get 0.8379 or 83.79% efficient. Okay, so that's how you combine efficiencies. You also need to know how to calculate in both directions. So there's two types of questions you'll be asked in the system efficiency module. The first one will be, you require X amount of energy. How much energy do I need to create before losses? Okay, the other way you get asked the question would be, you have an X amount of energy being generated and how much energy will come out the other end after loss. And we'll do a couple of example questions on those. All right, so how do we calculate how much energy we need before losses? Okay, so when we get told how much energy we require before losses, you must divide by your efficiency. Easy way to remember is if the number needs to get bigger, you need to divide by efficiencies, not multiply. So for example, let's say we need 10 kilowatt hour to charge a battery and the system is 80% efficient. How much energy do I need to generate? Obviously I'm going to need more than 10 kilowatt hours, right? Because we know it's not 100% efficient. So the way we work that out is we do 10 divided by 0.8 and we see that we need 12.5 kilowatt hours to charge our 10 kilowatt hour battery in an 80% efficient system. The other question you will get is how much energy do I have after losses? Okay, so when we get given a number, say we're generating a certain amount of energy, and we want to know how much energy is going to come out the other end of the system, we know there's going to be loss, right? So the number's going to get smaller. If the number's going to get smaller, you have to multiply by your efficiencies. Okay, so let's say I'm generating 10 kilowatt hours and my system is 80% efficient. How much energy am I yielding? So how much energy am I getting out the other end of my 80% efficient system? So you do 10 multiplied by 0.8 and you'll see we are yielding 8 kilowatt hours. Okay, so remember, when your number needs to get bigger, divide by efficiencies. When your number needs to get smaller, multiply by efficiencies. Now let's do an example problem where we're going to combine some efficiencies. Now these questions should look familiar to anyone who's attempted the system efficiency modules in our Grid Connect with Battery course. So we're going to quickly work out the efficiency to charge the battery from PV, our efficiency to charge the battery from the grid, our efficiency to supply loads from the PV, and our efficiency to supply loads from the battery. So let's work through them one by one. Alright, first we're going to look at our efficiency to charge the battery from the PV. So the first thing we do is we trace out our circuit path, okay, our path from our PV array to the battery. And then we can see across that circuit path we've got 1% volt drop on our first bit of cable, which is 99% efficient. Our charge controller is 94% efficient. We've got two sections at 0.5% volt drop or 99.5% efficient, and our battery is 80% efficient. So to combine all those efficiencies, we multiply them together, 0.99 times 0.94 times 0.995 times 0.995 times 0.8, and we get 0.737 or 73.7% efficient. And now we're going to look at the efficiency to charge the battery from the grid. So same process. First of all, we look at our circuit path, and we can see that we have a little bit of 1% volt drop on the AC side of the inverter, so 99% efficient. We got a 96% efficient inverter. We've got two sections at 0.5% volt drop or 99.5% efficient, and we have 80% battery efficiency. So we combine all those together as a decimal, and you can see we get 0.7527 or 75.27% efficient to charge the battery from the grid. Now we might look at our efficiency to supply loads directly from the PV. Right, so let's just go through this one pretty quickly. Exactly the same process. We find our circuit path. Okay, we have a look at our values as we move through that circuit path. We've got 99% volt drop, 94% on the charge controller, two sections at 99.5% efficient for the volt drop, and then we go through the inverter, which is 96% efficient, and 1% on the AC side of the inverter, or 99% efficient. Combine all those together, and we see to supply loads directly from the PV, that is 87.56% efficient. Now the last one we're going to look at is to supply the loads from the battery. Now, first of all, same as last time, let's look at our circuit path. But this probably trips up a lot of people. We don't include the battery efficiency as we included it on the charging cycle. Okay, battery efficiency is usually a round trip efficiency, so it's a total efficiency of energy in and energy out. So because it's the total efficiency of the battery, you only include it once. If you included it on the way in and on the way out, you would be shortchanging yourself on the energy you'd get out of the battery. So let's follow our circuit path. All right, ignoring our battery efficiency, we've got 99.5% volt drop, and then another section of 0.5% or 99.5% volt drop. We go through our 96% efficient inverter, and then we've got 1% on the AC side or 99% volt drop on that side. We combine them all together, we get 0.9409 or 94.09% efficient when we are supplying loads from the battery. And that's pretty quick rundown on how we combine efficiencies when we're looking at any of the questions in the system efficiency module. Now the other questions you'll get in this module are how we calculate yields. Okay, so let's have a look at another quick example problem. Our array is making 15 kilowatt hours per day. We want to know how much energy will be consumed to charge the battery. We want to know how much of that energy will go direct to loads from PV after charging the battery. Okay, so we know that the array is making 15 kilowatt hours up at the array. So first of all, we've got to work out how much energy we need to charge the battery. So same as last time, we look for our circuit path. right? We work out our circuit path from our battery to our array. But in this case, we need to make sure we're working backwards. We know how much energy we require at the load. So how much energy do we need at the array? We need to divide. Okay, so our circuit path is from our 4 kilowatt hour battery. We've got 99.5% volt drop on the DC cable. Our inverter is 96% efficient. Our next section of cable is 0.5% loss or 99.5% efficient. Another section at 99.5%. Then we move through our PV inverter at 97% efficient, and we've got 1% volt drop on the DC cable from the PV inverter to the array. So we take our 4 kilowatt hours and we divide them by all of the efficiencies that our circuit path heads through. So 4 divided by 0.995, divided by 0.96, divided by 0.995, divided by 0.995, divide by 0.97, divide by 0.99, and we see that we will require 4.4 kilowatt hours at the array to charge our 4 kilowatt hour battery. Okay, that's what we will need. So we know how much energy the battery will be consuming each day. Now we want to know of the 15 kilowatt hours the array is producing each day, how much of that is going to the grid. We know we are consuming 4.4 of that to charge the battery. We know our array is generating 15 kilowatt hours. So we do 15 minus 4.4, and we can see we've got 10.6 kilowatt hours left at the array. Now we want to work out how much of that is actually getting to the loads. So again, let's look at our circuit path from our array to our loads, and we can see that we've got, this time we're going to work forwards, right? So this time we want our number to get smaller. We know we've got 99.5% volt drop, 97% inverter efficiency, and 2 sections at 99.5% efficient for volt drop. We know we've got 10.6 kilowatt hours left over after charging the battery. So we do 10.6 times 0.995 times 0.97 times 0.995 times 0.995, and we can see we will be exporting to the grid 10.12 kilowatt hours. That pretty much wraps it up. That is all the different ways you'll need to do your calculations in the system efficiency module. I hope this video is helpful to a few of our students. As always, if you need any help, make sure you're reaching out via email or WhatsApp, and I will usually get back to you within 24 hours. Thank you.